All right, so in this lesson, I'm going to discuss the difference between physical and chemical changes. Now, a physical change, what happens in a physical change is that the appearance of a substance might change, but the chemical identity of that substance does not change. All right, so if we look, for example, at water, what would a physical change that involves water look like? Well, if you have, let's say, solid water, so I'm going to draw my water molecules. Okay, so there's water right there, and it's a solid. Notice we know it's a solid because the molecules are tightly packed together. If I were to melt this, which is going to be a physical change, what this would look like is the water molecules would then become liquid and they would take the shape of the container they're in. But notice as I'm drawing this, the identity of the water does not change. You still have water molecules there. So while the appearance might change, the chemical identity does not change. In a chemical change, what's occurring is the chemical identity of the substance changes. So what exactly would this look like? Well, let's look at the water example again. So I've got two water molecules here. If I allow them to react, what will happen is the following will form. The water itself will break apart and you will form two molecules of hydrogen, and then you will also have one molecule of oxygen. So notice here the reaction itself, what it looks like is the following. So I am changing the identity of the substance because I'm taking water and I'm converting it into hydrogen gas molecules and oxygen. Now a quick cheat for you to be able to use to distinguish between a physical and a chemical change. In a chemical change, for the most part, you cannot get the substance back. While in a physical change, you can get the substance back. You can undo the change. So I'm going to write out, you can get the substance back. Okay, so I'm going to go through these 4 examples and show what I mean by this concept of the identity changing or not changing and what I mean by if I can get a substance back or not. All right, when I dissolve salt in water, and you're taking salt molecules, you're allowing them to dissolve in water, but you are not changing the identity of the substance. You still have salt and it is now in water. So that is going to be a physical change. Now, I can actually get my salt back after I dissolve it in water. And the way you get it back is by simply evaporating the water, and what would be left is just the salt. So I have now undone that change, therefore it is going to be a physical change. If I burn a marshmallow, when I'm burning something that is actually a type of chemical reaction, it is a combustion reaction, and I am changing the identity of the marshmallow. It is being burned, and I cannot get that substance back. It will be charred no matter what I do. So that is a chemical change. I'm changing the identity of the marshmallow. When iron rusts, the process of iron rusting is iron reacting with oxygen. And it actually produces a new substance, and that new substance is iron oxide. Okay, so this is actually going to be a chemical change. So when iron rusts, you can't, another way to prove that it's a chemical reaction, you can't undo that. You can't get rid of rust once rust has formed. The only way to get rid of it, in quotes, is to actually remove the layer of rust that has formed. You're never going to get the original iron back, so that's why it is a chemical change. And finally, for water boiling, just like we saw up above here where you had water melting, when you're boiling water, you are not changing the identity of the substance. It is going to stay water. It's just that the molecules are now going to be moving more quickly, so that is going to be a physical change. Now, the last thing I need to discuss are the 5 different evidences that we will see for a chemical change. So if a chemical change occurs, you're going to see at least one of these 5 evidences. All right, so the first one is a temperature change. Now, if the temperature of a solution increases, then that reaction is said to be exothermic because the heat is leaving the system and what you feel is an increase in temperature. If the temperature decreases, then it is said that it is endothermic because the solution is removing heat from the surroundings. So you would actually experience a decrease in temperature. So if all of a sudden you combine 2 solutions together or 2 substances together and a temperature change occurs, whether it's an increase in temperature or a decrease in temperature, that tells us that a chemical change occurred. The second evidence of a chemical change is a color change. Now, by color change, I don't mean I took blue food dye and I added it to water and the water changed color, it became blue. That's not a color change. I know where that blue came from. It came from the blue food dye. When I say a color change, I mean I add 2 clear solutions together and I suddenly get a yellow solution or I suddenly get a white solution. That would be a color change. The third evidence is the formation of a solid. And we call that solid a precipitate. So if you have 2 solutions that are being combined together and all of a sudden a solid forms, a precipitate forms, we know that a chemical reaction or a chemical change occurred. And the 4th evidence of a chemical change is the formation of a gas. And if that occurs in a solution, what you would see with your eyeballs is you would see bubbles forming. And finally, the last evidence of a chemical change, which students don't appreciate when they're in my lab, is an odor being produced. Okay, so at least one of these 5 evidences of a chemical change has to occur for you to be able to confirm that yes, indeed, a chemical change has occurred.